Okay, so let's discuss now the scalar quantities. Practice set number 1. Which of this unit is a scalar quantity? Now, let's try to see which of this unit is a scalar quantity. Now, we all know that one of the scalar quantity is speed. In fact, velocity is vector. So this one is a vector. Speed is a scalar quantity that is defined as distance per time. Acceleration is also a vector, and displacement is also a vector. Okay, so later we're gonna tackle what is the difference between displacement versus distance when we discuss vector. Okay, so for now we're just gonna memorize that speed as the definition for distance per time. It is defined as a scalar quantity. Okay, number 2, all of these examples are scalar quantities except for, so density is a scalar, intensity is also a scalar, work is a scalar quantity, or energy is a scalar quantity, force is a vector quantity. Okay, how about number 3? A car headed 17 meters north and 24 meters east. What is the total distance? Now take note, distance is a scalar quantity. So you don't do it like this. You don't do the Pythagorean theorem. So for example, we have 24 meters, and then we'll try. So this one is called as displacement, and that is a vector quantity. We don't do that here right now because we are just asked for a scalar quantity. So that is just simply 17 plus 24, and that will gonna be 41 meters. So the answer for number 3 is letter A. Next, how about number 4? The formula for work is FD. Which of this statement is correct about work? So letter A, the unit of work is joules per seconds or watts. No, the unit of work is just joules. The unit of work is just joules, while watts is for power. Okay, now how about letter B? If force is doubled, work will decrease in half. You have to watch my previous video about this. So since work is equals to FD, and if you try to derive here, work over force equals to D, and look the relationship between force and the D, they are inversely proportional. So what does it mean? It means that, okay, so actually we're looking for, let me just correct this one. It's not force and D, but rather we're looking for the relationship between work and force. Okay, so if you can look force and work, work is directly proportional to force. So meaning to say increasing the work will also increase the force, or doubling the work will also double the force. So letter B is wrong, okay, since it should be also doubled. Now, how about letter C? Force and distance is in direct proportion. Okay, so this is, I think, the explanation behind. Force and distance is a direct proportion. No, because force is inversely proportional with the distance, with a constant work, of course. So, meaning to say, increasing force would entail a decrease in distance if the work should be constant. Okay, so this one, they should be inverse. And for letter D, it's correct answer. Work is a scalar quantity. Now, how about this number 5? Which of these does not belong to the group? So this one is a unit for density, because we all know that density is defined as mass per volume. This one is a unit for acceleration, because that is meter per second squared. So this one is a vector quantity. This one is for time. So this one is for temperature. Now, if we're gonna look here, these are all scalar, scalar, and then scalar. Okay, so the answer here is letter B, because it is an acceleration, it is a vector quantity. And number 6, which of these devices can only measure a scalar quantity? Ruler can also measure displacement. So you could have east, north, so there's possibility that this one can measure not just scalar, but rather a vector quantity. How about spring balance? Spring balance can measure, it is a measurement for force. So therefore, it is a four vector quantity. Accelerometer is also, it can also measure acceleration. And therefore, the best answer here is calorimeter, simply because it measures energy or heat. Okay? And so that talks about our scalar quantity discussion. The next topic would be vector quantities.